So, this is going to be a very basic introduction towards electronics and solving series parallel circuits. Right here, I just have a random series circuit problem that has a 9-volt source, a 3K ohm resistor, a 10K ohm resistor, and a 5K ohm resistor. And we're going to be looking to solve for current and power. So this is just going to go through all the steps on how to do that. And yeah, we're just going to go ahead and get started. So bringing it over to my iPad, I just recreated the circuit right here. So what we want to do eventually is make all these 3 resistors like this. 1 resistor in a series circuit. So the way we do that is just adding them straight up. We can add the 3K ohm resistor, the 10K ohm resistor, and the 5K ohm resistor together. So let's just do that. 3K plus 10K plus 5K. And if you just add this straight up, you're going to get 18K ohms. So this could be known as resistance total, or in this case, RT. So RT is going to be equal to 18K ohms. And what do we know so far? We know that the voltage total, VT, is going to be equal to 9 volts, and we're trying to find IT. So how do we find IT? We can do that by using this little trick here, V over I times R, in which you cover up whatever you're trying to find, and it will show you the operation to use. So let's say, for instance, we're looking for the current. We're trying to find I, so we're going to cover that up. And the way you find that is by dividing the voltage by the resistance. So let's do that here. You know the voltage is going to be 9 volts. And we know that the resistance is going to be 18K ohms. So let's just put it in our calculator. 9 divided by 18,000, or 18K. That's going to be equal to 0.0005 amps. And let's just convert that by bringing the decimal point back a couple. It's going to be equal to 500 microamps. Okay. So that's going to be our current total. And because it's in series, each resistor is going to get the same amount of current. So we know that our IT is going to be 500 microamps. So that means IR1 is equal to 500 microamps. IR2 is equal to 500 microamps, and IR3 is equal to 500 microamps. So what can we do with this? We can now find the individual voltage drop for each resistor. So basically how much voltage is being used for this resistor, this one, and this one individually. And the way to do that is by going back to our little graph right here. So we're going to be looking for voltage. So let's circle that, and we're going to cover it up. So the way to find voltage is to multiply the current and the resistance. So let's go ahead and give that a try. We know that that R1 is going to be equal to 3K. Let's just make that blue. 3K ohms. R2 is equal to 10K. And R3 is equal to 5K ohms. And we already found before that each resistor is going to have the same amount of current. So putting it into our calculator, we can take 3K ohms and multiply that by 500 microamps, and that's going to give us our voltage total. So let's just do that. 3K times 500 microamps is going to be equal to 1.5 volts. And let's just do that for the rest of them. 10K ohms times 500 microamps. And let's do it for the 5K ohms times 500 microamps. Okay. So putting that into the calculator, 10K ohms times 500 microamps is going to be equal to 5 volts, and 5K multiplied by 500 microamps is equal to 2.5 volts. So ideally, each of these added up should be equal to our voltage total. So our voltage total is 9 volts. So 1.5 volts plus 5 volts plus 2.5 volts. If you put it in your calculator to just double check, we get our total of 9 volts. Perfect. So now we know the voltage drop across each resistor. It's going to be VR1, VR2, and VR3. 1.5 volts, 5 volts, and 2.5 volts. Okay. Let's just erase this since we already have it written down. Now, for the final step, we're going to try and solve for the power going across each resistor. So to do that, we can do it a couple of ways, but the way I like doing it most is multiplying the voltage by the current. So V times I equals P. That's R equals P. So our voltage for resistor 1 is 1.5 volts. And we're multiplying that by 500 microamps. And that's going to be equal to our power source. So let's just do it for the rest of them. 5 volts multiplied by 500 microamps. And then our last one, 2.5 volts times 500 microamps. So let's just plug that into our calculator. All right, we're going to get 0.00075 watts. And that's going to convert into 75 microwatts. Caught myself in a mistake. Here we go. Instead, we're going to do the conversion. We're going to bring it back 1, 2, 3, 4, 5, and 6. It's going to be equal to 750 microwatts. And mistakes do happen, but it's always good to just double check your work so that you don't lose unnecessary points. So going to the next one, we're going to take 5 volts and multiply it by 500 microamps, and that's going to give us 0.0025 watts, or 2.5 milliwatts. All right. 100. And now let's just do it for the last one. We have 2.5 multiplied by 500 microamps is going to be equal to 0.00125 just watts. And then we're going to convert that by doing 1.25 milliwatts. Okay, so this is going to be our power going through each resistor. So let's just write it down. PR1, PR2, and PR3 equals 750 microwatts, 2.5 milliwatts, and 1.25 milliwatts. And we can find the total power by doing it two ways. We can either add up our individual powers, or we can just take our voltage total and multiply it by the current total. So let's just do it that way. So we have 9 volts, and we're multiplying it by 500 microamps. And now putting that into the calculator, we have 500 microamps is going to be equal to 0.0045 milliwatts, or it's going to be 4.5. Caught myself with another mistake. It's just going to be watts. 4.5 milliwatts. So let's just double check our work. We have 4.5 milliwatts, and we're subtracting it by 750 microwatts, and subtracting it by 2.5 milliwatts and 1.25 milliwatts. So let's just do that. 4.5 EE negative 3 minus 750 EE negative 6 minus 2.5 EE negative 3 minus 1.25 EE negative 3. And it gets us a total of 0, meaning we are correct. And that's it for dealing with simple series circuits. And let's just double check our work by putting it online. So here is another tool. It's called Multisim. It's a free tool where you are able to build series circuits and work through your answers. It's like double checking your work. So let's just go through how to build a circuit. So we have our power source. Well, it's always good to have ground first. But we have our power source. Let's see. Right here. We're working with 9 volts. And we're going to have our resistor. And let's just copy it a couple times. And there you go. The first one was 3K ohms. The next one is 10K ohms. And the last one is going to be 5K ohms. All right, there you go. Let's get it all connected. Now, this version of Multisim is a little bit bugged because it's the free version. There's a paid version that I might get later on, which works a lot better. So what we're not going to do is find the voltage drop for each one, but what we can do is take a current or an ammeter right here. And ideally, when we start our circuit, you see right here, 500 microamps. So if we just perform our calculations like before, we will get the same voltage drop across each. And yeah, that's about it. Thank you, everybody, and I'm signing off.